Shall we just start? So, I'm not sure if anyone's compere in the truck, but we don't need them. My name's Phoenix, and I'm talking, the talk's entitled Connecting the Dots. So what is the talk about? Well, so it's a little bit about big data. Yeah, I know. As we know, big data is defined as anything that crashes Excel. It's a little bit about third-party data breaches, and it's a lot about finding a way. So what this talk should have been called is Search is Hard. I'm not sure if you read the abstract in the schedule, but this talks about building a search engine for third-party data breaches. Not a breach notification platform, but an actual kind of like showdown of data dumps. So when I started, I had this basic idea that I would take the Ashley Madison and adult friend finder dumps from a couple of years ago and see if we could get like a search-like experience out of it. Why don't you index these dumps? And with like everything, it was a lot easier said than done. And there's a few different ways that you could go about doing something like this. The traditional way that I've seen so far about how you would build a search engine of data dumps would be to export the data dumps into whatever the native DB was and then put something in front of it. So if it was a Postgres dump, virtualize a Postgres or MySQL or so on and so forth, right? And I took a different approach. What I did was modify the ELK stack. And if you don't know what ELK is, it's Elasticsearch, Logstash, and Kibana. Interesting story. Doing this project, I absolutely smashed Logstash into little pieces. When I first indexed Ashley Madison with like trying to use Logstash to push it into Elasticsearch, it would fall over after about 3 days. It would fall over, wouldn't have inserted any records, wow, a third of the records, and it would completely die on its ass. So I managed to replace it with all things. You know it's bad when your tool is replaced by curl, right? So I ended up using curl and a parser called JQ, and boom. We went from taking 3 days and going nowhere to taking 30 minutes to put in 128 million records, right? So, yeah. So modified. We had this basic methodology where we would take third-party data dumps, analyze them, edit them, turn them into JSON documents, insert them and realize that we screwed up and that there were some problems in the key value fields, and then we would start again. So this kind of repeat, rinse sort of mentality. But what we were left with was something that was kind of actually pretty cool. We were left with like a REST API key value pair search over multiple databases simultaneously, multiple data breaches. So we were able to look at the time, 4 different databases from leaks. So Ashley Madison, adult friend finder, that lulsec porn list, and a few other things. And we were able to search that really, really fast. Now, you could say that we're reinventing the wheel a little bit, because you could have done that with grep. But we were getting results back in 2 or 3 seconds. Good luck doing that with grep, right? It also enabled us to do conditional type of searches. So if this condition is met, then search upon this, da-da-da-da-da. Kind of really the difference between search and filter is what's coming on here. As I said earlier on, it kind of speaks JSON. And what I mean by this is everything that we stick into the search engine is JSON, because it's basically a document store with full text search when it boils down to it. So everything we stick in is JSON, and everything we get back is JSON too, which if you've ever worked with JSON a little, you probably hate it, right? Pro tip, if you're not nesting JSON, you're not doing JSON, right? But don't actually undervalue or underestimate the benefit of having such a defined standard to work with data sets when they come back. It enables you to be able to script very, very easily, very, very quickly, because you know what you're going to expect. It's not unknown. So it's actually hugely cool, especially when you think that all of these data dumps that we got came out in different formats. So Adult Friend Finder was CSV and some XL. I think Adult Friend Ashley Madison was MySQL. And a few other dumps come in these strange formats. So like I say, it's kind of cool to get JSON here, right? Although whenever I deal with hackers the first time working with the tool that we built, I spend just as much amount of time explaining to them that their JSON is crap and that they have to work better on it. They go through this life cycle of about 3 weeks, and then they get how JSON works. It's quite strange. So in the beginning, we only had a couple of dumps. And it became quite clear that we needed to have more data. And this is what we did. It all sounds quite interesting so far. So when we started looking for data, I'm like, that looks like an interesting data dump. Let's index it. So much stress, regardless of what you use, because any problem that you get in the web world, you're going to get in JSON too, right? So when you've taken data out of a database and converted it into JSON, right? Comment fields and stuff like this. There's smileys in your dating profile title may look cool, but as far as JSON's concerned, you've got a screwy key value pair, and whatever you're using to index it will remind you about this constantly. So yeah, this happened a lot. I'm like, wow, that one's really cool, and this one's really cool, and then I would spend weeks trying to get through how we would do it. So after we had the first 3 initial databases, I spoke at Berlin sides about what we got up to and what we found. It was quite interesting, and people started pointing me to locations of other public dumps. And we added Mate1. Hands up if you've heard of Mate1. Come on, don't be shy. No one in this room has heard of Mate1. One person. Right, okay. So Mate1 was a dating website. The difference between like Ashley Madison and Adult Friend Finder is they were those dumps were like, Ashley Madison was looking for, they were looking for people to cheat with, but I think most people were just speaking to bots, to be honest with you, if you've ever looked at the data dump. Mate1 was a little bit different. It was like a traditional dating website. What was interesting about it, though, is it gave us millions and millions of plain text passwords. Lol, Mate1, why did you store your passwords in plain text? Well, I'll discuss later on that it's not the worst sin in the world, right? I mean, it is, but they're not alone. So it gave us millions and millions of plain text passwords, which was quite interesting because when we had Ashley Madison beforehand, Ashley Madison used bcrypt to encrypt its password hashes. In some cases, they totally screwed that up, which was quite interesting. Maybe someone can ask me about it in the questions later on, what they did. Lol. And then we added LinkedIn afterwards, which is strange because I probably should have started with LinkedIn, right? Because this one was quite old at the time. But what happened, there was kind of this mental change for me when this happened, because beforehand we had this like dating website dump search engine. So you were never guaranteed to find your clients in there, right? And it was always lol when you did. But when we added LinkedIn, what ultimately happened is we were able to tell, all of a sudden it started going from lol to finding people all the time, and then being able to tell if they were Ashley Madison or Adult Friend Finder users or Mate1 users on top of that, if they'd used the same email addresses. And trust me, unbelievable amount of people did that. So yeah, this was kind of interesting. Kind of interesting for a few things. If you remember what was the problem with LinkedIn's data dump in 2012, yay, they didn't sort their hashes. And that led to a kind of more interesting turn later on. As I said also earlier on, it was also non-dating related data sets, right? So beforehand it was quite specific and niche, and it kind of grew. further on. And no idea how many people were in multiple data sets, if not all of them. And if you think that's like, I mean, I'm sure you all heard the headlines when Ashley Madison happened of all the people inside the Ashley Madison data dump. But they're literally a huge amount of corporations that lost their corporate identities inside dating websites. Huge. And when you're able to connect the dots later on, it's quite interesting. Funny story, Boeing got a huge amount of flack over the Ashley Madison stuff. There was a lot of blog posts about it. They had 153 accounts in there. Yeah, great move, right? Let's sign up to have an affair with a Python bot, but let's use our Boeing email address to do it. If you think that's bad, they had one user that signed up 13 separate times with his Boeing account. Needless to say, he's probably got one of the most locked down social media profiles you've ever seen in your life, right? I think they learned the lesson quite a lot. But this wasn't alone, right? This is carried on. Also with the Ashley Madison data set, if you think that's unbelievable, you would be surprised how many BBC people are in the Ashley Madison data dump. Scott Mills denies that he was in there, that someone had put his email address in there. The problem with Ashley Madison is that Ashley Madison had this tag, this key field that was is valid 1 or is valid 0. And is valid 1 was I clicked the link to validate my email address. You can take a guess what Scott Mills' is valid status was. But yeah, so it's surprising that you would have so many people do this, right? Because if you think, right, I'm going to use my work email address so the people at home don't know. Like, yeah, okay, but the people at work know. So yeah, as I said, you would be hugely surprised. It's quite interesting problem because Ashley Madison was a bit different as a data dump because it was so widespread in its publicity. C-suite was interested and looked into it, but there was loads of dumps where users from corporations have used their email addresses in places you really shouldn't be doing it. So yeah, non-dating, very, very interesting. No. It also made me, LinkedIn made me really interested because we'd started to accumulate a lot of plain text passwords through data dumps, but we also had started to accumulate unsalted hashes. And kind of an interesting story because unsalted hashes, you know when I picked on mate one earlier on for the plain text passwords? Well, really an unsalted hash isn't much better, really not much better. And you'd be surprised at how many dumps are unsalted SHA-1s or MD5s. It's against the norm to find something that is dynamically salted in a data dump. It's probably comparable to statically salted hashes and unsalted hashes. They're probably head and head. So it is really unusual. So in the end, what we did, we built an independent index of SHA-1s and MD5 hashes. So if you've ever heard of the website Zoosk, it's another dating website, right? They used MD5s. And it went across the board, there was quite a few. So we built this independent index. You could, like in a record, it would be the SHA-1, the MD5, and the plain text. So what you could use is a REST API, push the SHA-1 to the REST API, and the REST API would come back to you in about 2 seconds and say, oh, we know that password, and that is this, right? So it now has 1.3 billion different hashes that you can search for. So this, it's kind of cool, right? Like, you can crack these hashes on any rig that you've got, but I can guarantee you if we've seen it before, we'll get it pretty quick, like seconds. It's kind of like polishing off old stuff here, though, right? Because really, try to think of rainbow tables, but elastic tables. And it's hugely effective. What's also interesting is MySpace. A, that MySpace is still a thing, and B, that MySpace gave us, I can't remember what the total leak of data was, but it was quite, I think it was in the 200 millions, maybe even 300 millions. And that was all SHA-1 as well, right? So all of a sudden, that elastic table lookup thing became really useful because you had LinkedIn and MySpace and a few other things, and it became incredibly effective. And as I said, the indexes are created with every word list that we could possibly find. And then any plain text that we came across in public data dumps, we also generated ND5s and SHA-1s. So now that independent index is, I would say, half generated from actual real-life passwords that have come out of data dumps. And the other half is from our traditional data sets, traditional word lists that we kind of get from GitHub or whatever. There was this big, there's a post about someone releasing 1 billion words for word lists recently, something like that. We took that word list and ran it against our system. I think there was 256 million different words that they'd released about 2 months ago. And we hadn't had 4 million of them, right? So, you know, we're doing quite well. And as I said before, it's continually being updated. And I think this is a massively interesting problem because what it means is that you could have quite a good password, right? But if someone else has that password and they put it into a website, you don't know anything about it, right? Once that plain text leaks, we've got that password, right? So you can be screwed by other people's password reuse and other people's sucky password storage too, right? Or as we like to say, another flawless victory, right? So I learned quite a lot working on this project, to be honest with you. Firstly, I learned that Vim users are the basic vegans of the internet. And anyone who knows a Vim user will know exactly what I'm talking about. I also learned that the internet has a lot of creative users. So there are some users that will use their point of sale device's password as their own password. And put this into context, I had someone speak to me about this recently. It wasn't the person at the cashier's desk that was using the POS device's passwords the last time we discovered this. It's like number 2 in organization. It's all fun and games until you have to password reset your credit card processing facilities. And this is just Adobe, right? And you can see we've just done a search on the password hint key field. But I suppose it could be a lot worse, right? I mean, who would use their VPN password, right? I stopped doing it at this point because we got VPN password, then we got bank password, then we got corporate network password, then we got work email password, and you're like, yo, stop using this stuff. And what's great about Adobe is they really screwed up their hashes. They're static, right? So you can search a hash and find other users in the Adobe database that have that hash. And then you can have their password hint fields too for the same password. It's like a crossword puzzle, but instead of getting 1 clue, you get 20 or 30, right? I ran into a few problems when I first started this because you can sum up the amount of knowledge that I knew about search engines on the head of a pinhead, right? I absolutely knew nothing. And luckily enough, Elasticsearch is dangerous enough to let an idiot like me do something like this, right? But it's not smart enough to keep me out of danger later on. So when I first started, I had, it went quite well, 128 million records, fast, nice, sweet, very, very cool. Got past 1 billion documents. And yo, that's when shit got really freaky, right? Like, Elasticsearch is not my friend. And it turned out that I made some like fundamental flaws in how I was doing things, not quite understanding the technology as well as I should have. And needless to say, when I redid the indexes and, you know, made sure we used analyzing quite sparely, and we worked on sharding a little bit better, so on and so forth, we managed to iron the problems out of using something like Elasticsearch. Elasticsearch is very, very, very cool. Hands up if you've heard of Elasticsearch before or used it. Right? If you are using Elasticsearch and you've not got a reverse proxy in front of it, right, you're an idiot. There is absolutely no security in this thing period. And they fixed all their security issues by not implementing any whatsoever at all. If you find an Elasticsearch deployment, you're going to find it on like 9200. It's highly unlikely that it has any access control. But something like curl-x-delete, whatever the URL is, _all is the equivalent of drop tables. Except there is no authentication period. It's just a curl request off the internet. And who remembers like when all those MongoDBs got busted last year? Someone wrote a worm and it pulled all the data down, encrypted, da-da-da-da-da. Elasticsearch got owned right on the back of it. And I'd been saying like the 6 months beforehand, yo, just get Nginx in front of it. It'll be cool, right? It'll be fine. And then that happened. All of a sudden, there's a lot of Nginx out there. But yeah, you'd be surprised as well how many people are using Elasticsearch as a non-traditional database as well. Preliminary searches have shown that you're going to find corporations like, like their internal directories for the companies and stuff like that. You're going to find a whole host of data out there in Elasticsearch land where like some Node.js developer has written a front end to store data in Elasticsearch. So you will find sensitive information out there stored in Elasticsearch. There is a security plugin, but they make you pay for it. Which, of course, I kind of have a little bit of an issue that you're going to charge someone $1,200 to make sure they don't get pwned. Write secure shit, right? So once we got to this is a big problem. We fixed it. It was cool. So going back to Ashley Madison. Things were like simple when it was Ashley Madison. Ashley Madison is actually quite a complex dump to process, because if anyone's ever like viewed the Ashley Madison dump, it's spread over 5 databases. Basically 5 tables, databases, not tables, which is quite complex when you're trying to convert from this relational database kind of schema into this kind of document store kind of way of doing things, right? So you get some liberty, but you also, a lot of freedom comes a lot of responsibility and twice as many ways to shoot yourself in the foot. So yeah, when we did this, it was quite interesting. We got quite a few, but we ran into problems. Because what happens with this stuff is you inherit the complexity of whatever the database is. So if the database is 5 different databases that are hooked together, right, you've got that complexity in a standard data store, right? It's quite a pain in the ass. Also, if anyone's got like DBAs under, like in your remit, you should totally go and work with these people, right? Because there's a lot of stuff happening in database land that's just whack, right? Also, what's interesting, it took me a while to work out, but absolutely everybody stores their data differently. And it's not, what I don't mean is you're going to see Postgres and MySQL and so on and so forth, but what you're going to find is that the field values, the field names, are almost as unique as the individual that built the database. So one man's handle is another man's nickname, is another man's email, right? And of course, when you want to do searches on this stuff, you want your searches to be uniformed. I want to search for email. I don't want to search for email and username and nickname and da-da-da-da-da. So there's a period of normalization that you need to do as well. And this is one of the kind of really interesting lessons that we learned early on. So when we first built the search engine, we do this kind of traditional way that you would think about searching, right? So email, wildcard at example.tld, right? So of course, that's the way you'd think about searching it. And the problem is, wildcard searching is incredibly expensive on a server, and even more so on Elasticsearch. So we ran into huge problems once we got into 1 billion records, right? This is tanning our ass. And eventually I realized that what we really needed is a domain key. So we went through all the data sets, took email addresses, and then we basically just used Python and just went, split ampersand 1. And we took everything after the ampersand. We built a key into the new data sets, and now you can just do like domain at example.com. And because there's no wildcard searching in there, what you get is incredibly fast results, really fast. Because the truth of the matter is it's about understanding the type of searches that you want to do, right? And if you know that earlier on, and this is quite a kind of like it's not uncommon to think about, I'd like to search my corporate domain, but I don't want it to take me 240 seconds to do it. So analyzing and understanding how you're going to search that database later on when you index it is actually quite important. Pretty soon you end up with data about data, and a huge amount of data about data. When people tell you that, oh, we just collect metadata, it's nothing to worry about. It's all fun and games until you end up in someone's index, right? So yeah, we generated quite a lot of data, just about the data that we've collected. I talk about that in the conclusion section. So, the greatest face ever for security that's ever been, by the way, right? He actually looks like this in real life. So much more fun. So, you can't really talk about this project in some ways without addressing the elephant in the room of, you just built a search engine of data dumps. Don't you think that that might be a little bit dangerous? Yeah, I do, in a lot of ways, right? The problem is it's really a case of stable doors and barns, right? So yes, we built a search engine that currently has about 56 different databases in it that we can search simultaneously from third-party data breaches. And we do it pretty quickly. You can speak to it in a REST API, you speak to it in Python, blah, 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 right? So a lot of people freak out about the privacy side of it, and I can totally understand. But the truth of the matter is, you could delete this tool today, and nothing would change. The thing is still out there. And I think what justifies this recently, if you've heard of the mother of all dumps, have you heard of this over the past couple of days? It was maybe a month ago. Troy Hunt had released a lot of emails about the mother of all dumps to people. And what this is a dump that was found in the wild. That is an accumulation of lots of other dumps. So it's got cracked Ashley Madison passwords in there, an adult friend finder, and Zeus, and LinkedIn, and blah, 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 blah. It's about 500 million records long. Someone took the time to accumulate 500 million records and crack the hashes doing it. And then what you do is you grep for the hits that you're looking for. And we found this in the wild. So this is kind of exactly, we're a couple of steps ahead on this one, but this is exactly the same idea, right? This 500 million email addresses is their index, and grep is their curl on this, right? So it is happening, it is out there. And you also, I would say as well, when it comes to third-party data breaches, a lot of organizations don't have a clear idea of what they've actually lost, right? They'll know that they had some records in Ashley Madison, but they'll very rarely know that they were caught up in a phishing campaign, or that credentials were leaked on Payspin, or blah, 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 right? So it's kind of important. The data's already out there, right? And it's kind of important that we get some visibility about what's actually been leaked, because 2016 was a particularly vicious year in data dumps, right? I think Troy had said that there was 3 billion accounts affected by data breaches in 2016. I wouldn't disagree with that. My only issue there would be that they're the data dumps that Troy knows, and I was able to verify it too, right? These are only the data dumps that we're aware of. We have no idea what's in private hands, which is quite interesting, because it turned out that, 2012 was a vintage year for pwning databases. We just didn't know about it until 2015, right? And as I say earlier on, ignoring the problem is really, it doesn't matter, right? The data is out there in the billions and affecting people quite a lot. The other thing to also worry about here is that searching leaked databases for credentials is the most passive type of OSINT that you can get, right? You download the database and grep it locally. There ain't nobody anywhere gonna get an IOC to pick you up doing that anytime, ever. So yeah, it's mostly passive, mostly. There is times where you sometimes have to reach out. And this is quite worrying, right? Because it is out there, it is being traded. Anyone that's looked at data breaches will tell you that there is a virile market going on at the moment in data trading that's quite in depth. I used to think that we failed at teaching web developers input, right? You know, like, oh, we've got OWASP and we still get pwned by SQLi, right? I'm not going to blame the web developer. We've got organizations that have been teaching people and we're not winning. And now I realize after working with their databases for a while, we really suck at teaching DBAs basic security too. If you go and look in any data dump, right? If you don't believe me, just go and check any SQL and check the emails table. And what you'll find is there's absolutely no validation of those email addresses in there whatsoever at all. Nearly all cases that I've come across, you'll find AAA.xyz, you'll find all of this stuff going on in there. And they're not sanitizing. What's also interesting when you analyze data dumps as well, you can also see the enumeration before the SQL happens. So you watch accounts that are getting registered with username .. // password, right? All of this stuff going on. And then all of a sudden, end of file. You're like, I knew what happened there. But yeah, this is a big problem. And it's interesting because I did some looking at the Freedom Hosting dump. Have you guys heard of Freedom Hosting? Freedom Hosting was like a dark web service provider. Quite shady, if truth be told. And it's interesting because all the problems that you have in the ClearNet world all live inside Freedom Hosting too. So you have this huge mess of databases, huge poor deployed applications, blah, 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 blah. And what's even worse about it is it's impossible to tell the difference just from the SQLs, that one of them is applications being deployed in enterprise, and the other one is being deployed in the dark web. It's indistinguishable to tell which DBA did which, right? The quality is exactly the same, which is none. So if you have a look, go and verify this. It's quite interesting. And then we wonder why people get pwned. Now, I've gone through my slides pretty quickly, but luckily enough, I've got some time for just a couple of quick stats. So when I first started this, I had about 10 gigs of documents. The interesting thing when you convert data dumps to JSON is that you increase the raw size of the file. So if you've got a CSV file, that's maybe 3 fields, 3 columns. When you put it into JSON, what happens is you increase it by a factor of 3. Because beforehand, what happens is the field names, the key pairs, you've increased the byte space for the key pairs, right, and replicated it for each and every single record. So, like I say, if you've got a 3-column file that's 100 meg, the JSON's very likely to be 350-ish. Elasticsearch will add in some metadata too if you use that. So when we started, by the time we had Ashley Madison, an adult friend finder, and a few other things, we had 10 gig. So it was about a year and 2 months ago that we started on this. Today is a bit of a massive change, right? We now sit at 728 gigs of documents. And that's just a year of finding publicly available documents. If you missed that, that's like a factor of 72 times bigger in 14 months of just actually looking. When I started this, I also had around 127 million unique documents. And a document is just a record, and inside that record is associated data. So it could be inside that record, could be the email and the password and the username and so on and so forth. So this isn't unique pieces of information. This is unique documents with unique pieces of information inside it. So when we started, we had about 127 million. And now we're about 20 times more documents indexed. We're at 2.7 billion now. Now, to be fair, this number is also made up of the elastic tables thing that I was talking about earlier on as well. So, but I'll give you the useful number. This is the amount of unique emails that we've discovered that have been dumped in third-party data breaches from 2016 to today. So just under 1 billion unique email addresses that we find. And we don't validate in the sense that we send emails, but we ensure that the email is regex compliant, right? So yeah, if it's spurious, we'll just drop it. It's not worth the hassle. I only had 45 minutes, so I've left 10 minutes for questions. But that's everything from me today. So if you've got any questions, now would be the time for it, okay? Thank you.